Polynomials, the things that make the world go round. Look, a monomial is a single term. So if you look at 3x to the fourth, yeah, it's made up of 3 times x to the fourth, but it is one single term. It's a monomial. Once you start throwing in some pluses and minuses, it becomes a polynomial. And we'll have different ways to name those polynomials as well. Something very important is putting things in standard form. That's standard across all your math classes. You always write your highest exponents first, your highest degrees, and then you go down from there. But the degree is the number, it's the exponents on the variables, just the letters. So if you have like a regular number like 14, that just gets thrown on the end. Let's see what we got. Oh, wow. So if it is just a number, that's called a constant. Those are to the 0th degree, they go at the back. When something is to the first power, x to the first power, that's called a linear function. The second power is called quadratic, third power is cubic, fourth power is quartic, fifth power is quintic. And then we're also going to name it based on the number of terms. So if it's one term, it's a monomial. If it's 2 terms, just like a bicycle has 2 tires, a binomial is 2 terms, trinomial is 3, and then after you hit trinomial, you just say polynomial with blah 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 terms. So let's see what we got. Rewrite each polynomial in standard form, highest exponent first. Then identify the lead coefficient, degree, and the number of terms. It should be easy enough. All right, so rewriting this, 4x to the third has the highest exponent, so that should be written first. And then we'd have the 2x, because that's 2x to the first. And then we have that constant, that minus 1 at the back. So there it is in standard form. Now when it's asking for the lead coefficient, we'll just say LC, it's the number in front of the highest degree. So in this case, it would be the 4. The degree, now this is a polynomial, so you just go with the highest degree of a single monomial. And again, it's always going to be written first if it's in standard form. So this is a 3rd degree, or you could just say 3. And then it says, identify it based on the number of terms. There are 3 terms here, so that's called a trinomial. Now, if we're basing it off the degree and the trinomial, the number of terms, it's a 3rd degree, so we call that a cubic trinomial. So the cubic part is based on the degree, and then the trinomial is based on the number of terms. So let's try that again on this one. Highest exponent I see is this x to the 5th. X to the 5th. The next one would be the 7x to the 3rd. Then we'd have our negative 11x, and then you have your constant, your negative 2 at the back there. So our lead coefficient is the number in front. There's an invisible 1 there. What's next? The degree. This is the 5th degree because that's our highest exponent. And then naming it, again, we'll name it based on the degree and the number of terms. So 5th degree is quintic. So monomial's 1, binomial, trinomial. As soon as you go beyond 3, you just say polynomial with that many terms. So there's 4 terms here. So we're going to say a quintic polynomial with 4 terms. So I have 2 here for you to try. I think you should go ahead and pause it, try them, and then check back in because I'm going to do them right now. 2x squared plus 4x plus 2. X to the 3rd minus 18x to the 2nd plus 2x minus 5. And, oh, that's it. All right. So lead coefficient is negative 2. Over here, the lead coefficient is 1. The degree, this is the 2nd degree, which we call quadratic. And this one's third degree, which we call cubic. And then we'll name it. So this is a quadratic, and there are three terms. So we say that's a quadratic trinomial. Cool. This is the third degree, that's called cubic. And there are four terms here, so we say cubic polynomial with four terms. That was fun. Alrighty. Oh boy, now we're adding and subtracting? Come on. That's too difficult. So you can only add or subtract them if they have the exact same degree and combination of letters and exponents. The exponents have to be exactly the same. Now, I personally like to stack them vertically. This is not mandatory. You can leave it as is, but it makes more sense in my head and it helps me stay organized if I stack them in correct columns where the exponents are the same. So this first one is 3x to the second plus 7 plus x. If I was writing that in standard form, it would be 3x to the second, then plus x, and then plus the 7. So when I'm adding this other set of parentheses, I stack them. This is the only x to the third, so I'm going to give it its own column out in front. 14x to the third, because that'll keep it in standard form. And then I have this plus x squared, so I'll put that under my other x squareds. And then we have the minus x, and then we have the plus 2. So now I can just go down in columns, and then I'm done. So we have the 14x to the third. Now when you add, you don't change exponents. You only change them if you're multiplying or dividing. So 3x squared plus x squared is going to stay x squared. 3x squared plus 1x squared is 4x squared. Now look at those x's. You have x minus x. They just cancel out, so just get rid of them. And then you have 7 plus 2 is 9. And if you stack them in standard form from the get-go, then your answer's already going to be in standard form for you. Great. Adding, no problem. Subtracting, a bit of a doozy. Here's the old Josh Plant recommendation when you are doing subtraction. So first thing I'm going to do is I'm going to put this in standard form. I'm going to make it negative x squared. I'm going to leave some space for the regular x's because then I see the next term is just 1. So as obnoxious as that looks, that's how I'm going to write the first set of parentheses. When you have subtraction, here's the recommendation. Just make everything in the parentheses after the subtraction its opposite. So I'm going to make this 3x squared negative 3x squared. I'm going to make this plus 2x minus 2x. And I'm going to make this minus 5 positive 5. Because we're really doing minus each of those terms. And if you have minus negative 5, that's really the same as plus positive 5. So if you make the change immediately, then it just becomes just like the addition problem. So we'll go straight down here. Negative 1x squared minus 3x squared is negative 4x squared. We'll bring down our minus 2x, and then 1 plus 5 is 6. Boom, done. That wasn't too bad, right? Again, here's 2 for you to try, and I think this is it. So try them, check in when you're done, and then that's the end of the notes. Let me see if I can start this here. Folks, yar it is, and we're having fun.